Hey, today we're going to start some right angle trig. Ow, ow, ow. So we are going to find and use the sine, cosine, and tangent of an acute angle. And we're going to use our trigonometric ratios to find side lengths and right triangles and solve some problems. So by the AA angle-angle similarity postulate, a right triangle with a given acute angle is similar to every other right triangle with that same acute angle measure. So let's say, okay, that was a lot of words. Let's say that my smallest little triangle here has sides. Okay, these aren't the real side lengths. I'm just making something up so it's easy to see. Okay, let's say it has sides 3, 4, and 5. Okay, leg, hypotenuse. Now, in each of these triangles, I have a 90-degree angle and a 32-degree angle. So 90 and 30 would be 120, 120. So this one has to be 58. If you subtract 90 and 32 from 180, all three of these have the same missing angle of 58, okay? Because they all have to add up to 180. So what I wanted to show you about the sides is, like, let's say this is a 3, 4, 5, and these are not to scale, and these aren't even the real lengths, but let's say that this one was 6, 8, and 10, and this one was 15, 20, and 25. Okay, so if I take the ratio of BC to AC, BC to AC, that's 15 over 25. That should be equal to the ratio of EF over DF. So that's 3 over 5. And what is it saying? YZ over XZ. YZ over XZ. That would be 6 over 10. Now, if I reduce these, if I put 15 over 25 in my calculator, 15 divided by 25, and then I do math, enter, and reduce that fraction, I get 3/5. So when I reduce this fraction, I get 3/5. 3/5 is already 3/5. And you can see that if I reduce 6 over 10 and divide the top and the bottom by 3, just kidding, by 2. I don't know what I'm saying, it's early. By 2 divided by 2, okay, then I get 3/5 for that ratio as well. So because these triangles are all similar by the AA similarity postulate, okay, all of these ratios are going to be the same. All right, let's look down here. Okay, so these are defining specific ratios in the triangle. If we take the sine of an angle, that is the ratio of the side length of the leg opposite that angle to the length of the hypotenuse. So here, if I take the sine of angle A is here, I put the opposite, which is the little side A, over the hypotenuse. Okay. If I take the sine of angle B, its opposite is the little side B, and I put that over the hypotenuse, side C. So depending on which angle you're talking about, you'll have a different opposite leg. The hypotenuse is always the hypotenuse. Okay. All right. For cosine, instead of doing the opposite, you take the adjacent. So going back to angle A, if I start with angle A, its adjacent angle, that means the next to, I said angle, its adjacent side, adjacent leg is side B. So you put the adjacent over the hypotenuse. Okay, if I look at angle B, its adjacent side is side A. That's the adjacent. And you put that over the hypotenuse. Now for the tangent is defined as the opposite over the adjacent. So if I look back at angle A, okay, its opposite is side A, and its adjacent is side B. And then its opposite of that, it's the reverse, I should say, for angle B. The opposite is side B, and the adjacent would be side A. Okay, so these just define the ratios. Now, what might help you, and you've probably seen this on math classroom walls and been like, what the heck is that? To help you remember this, you can think of SOHCAHTOA. 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 So the sign is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over adjacent. Okay, let's practice. So we have to write the trigonometric ratio as a fraction and as a decimal rounded to the nearest hundred. So if I want the sine of j, the sine is, remember, the opposite over the hypotenuse. So I find angle j. Opposite of angle j is 60. The hypotenuse is always the long side across from the right angle. So that's 61. Okay, so that's as a fraction, and then I just put on my calculator 60 divided by 61. And I have to round it to the nearest hundred. So that is 0.98. Ooh, guys, I almost forgot. Before we do anything, we should really make sure that our calculator is in degree and not radian mode. So I want everybody to go to mode. Okay, mine's on radian, so I just did, I want you to turn it from radians into degrees because we're not going to mess with radians this year, I don't think. So make sure that your calculator is on degree and hit enter. Okay, and then you can quit out of there. Okay, so for the cosine of j, cosine, remember, is the adjacent over the hypotenuse. Remember, it's SOHCAHTOA. Okay, so find j. Oh, same angle. Okay, now the adjacent for j is the 11, and the hypotenuse is still 61. So the adjacent is 11, and the hypotenuse is 61. You put that in the calculator. I'm getting 0.18. Okay, and then we want the tangent of angle K. So if I look at angle K, its opposite is 11, and its adjacent is the 60. So tangent is the opposite over the adjacent. So that is 11 over 60. Put that in the calculator, and I get 0.18. Okay. We have to write each ratio as a fraction, and it is, okay, same directions. All right, cosine of A. Cosine is the adjacent over the hypotenuse. So if I look at angle A and I find the adjacent side and the hypotenuse, I have to put the 24 over the 25. Okay, put it in the calculator. I got 0.96. Okay, now we want the tangent of B. So remember that the tangent is the opposite over adjacent. So I find B and I find the opposite and the adjacent. So it's 24 over 7. Oops, not 27. 24 over 7. Okay, I got 3.43. Okay, sine of B. So sine is the opposite over hypotenuse. So I find my angle B, I look for the opposite, which is 24, and the hypotenuse is 25. Notice that the sine of B is the same as the cosine of A. That's kind of fun. In the same right triangle. Okay, so I don't need to put that in my calculator, I already did. So it's 0.96. Okay. Caution, be sure your calculator is in degree mode. Oh, we already did that. Whoop, whoop. Not in radian mode. On TI-84's press mode, scroll down to radian, press over to degree, and press enter to change to degree mode. Okay, we already did that. Use your calculator to find the trigonometric ratio and round to the nearest hundredth. So if I want to find the sine of 52 degrees, I can use my calculator to find that ratio. I can just put in sine. You see the little sine button? Sine of 52. This is when it's really important that you're in degree mode and not radians. So it said round to the nearest hundredth, so that would be 0.79. If I did math, enter. Okay, it's not wanting to do it. Okay, so we're just going to do 0.79. 0.79. So basically what they're saying is that if I took the opposite over the hypotenuse, it would be about 79 to 100. Okay, that's what it means. Okay, cosine of 19 degrees. We hit the cosine button. We do 19. I'm getting 0.95. So I got 0.95. And so what that means is the adjacent over the hypotenuse is about 95 over 100. Okay, if we do the tangent of 65, I got 2.14. 2.14, and that means that the opposite over adjacent would be, yikes. I'm having a brain fart, guys. Should I just make it over 100? It would be 214 over 100. It's like, do I do 100 or 1,000? I think 100 makes more sense. Okay. Use your calculator. Okay, these are exactly the same. We're not going to do these. Sorry, not sorry. Okay, the hypotenuse is always the longest side of a right triangle because it's opposite the biggest angle, which is 90 degrees. So the denominator of a sine or cosine ratio is always greater than the numerator. Therefore, the sine and cosine of an angle, acute angle, are always positive numbers less than 1. Okay, that makes sense. Since the tangent of an acute angle is the ratio of the lengths of the legs, it can have any value greater than 0. So if we go back and look at our other page, notice that all of our sines and cosines are between 1 and 0. They're all positive numbers smaller than 1. But the tangents can be bigger than 1. Okay. So we have to find the length BC, rounding to the nearest hundredth. BC is right here. Okay, so we have to use this little angle, this 15-degree angle. So for what we have here, we have the opposite and we have the adjacent. So the trig ratio that uses opposite and adjacent is tangent. So we want to say that the tangent of 15 degrees equals our opposite, which is 10.2, over our adjacent. Let's call this x. Okay. Now I can cross multiply, and this has a 1 under it, right? So I can multiply these two together and these two together and get a true equation. So that will be tangent of 15 degrees times x equals 10.2. Now to get x alone, I can just divide both sides by the tangent of 15 degrees. So I'm going to divide this side by tangent of 15 degrees and this side by tangent of 15 degrees. And those cancel. And this I can put in my calculator. So 10.2 divided by tangent of 15 degrees. 10.2 divided by tangent of 15 degrees. I got, what does it say to round to? Round to the nearest hundredth. Okay, so 38.07 is what I'm getting. 38.07. Now, the tangent is defined as a ratio. It is not an angle. okay? And when I'm solving for my x here, this x is a length. So I don't put degrees or anything on this because this x is a length. So my x is 38.07. Now I can check that by doing opposite over hypotenuse, and I should get the tangent of 15 degrees. So if I do tangent of 15, and then I do, what were they? 10.2 over 38.07. 10.2 divided by 38.07. I should get the same thing. Pow! And obviously it's a little bit different because we rounded. We have a little bit of a rounding error, but you can see that it's really close for a couple of decimal places. Okay, so that's how you can check your work. All right, let's try another one. All right, so looking at, okay, we have to find QR. QR, let's make that our x. Find, oh, we have to round to the nearest hundredth. Okay, so this x compared to our angle of 63 degrees, that is the opposite. And the 12.9 is the adjacent side. So the ratio that uses opposite over adjacent is sine. Okay, this one was tangent. Okay, so we're going to do x over 12.9 because that's the opposite over adjacent. Here, let me do opposite over adjacent. Okay, so that's x over 12.9 equals the sine of 63 degrees. Okay, now to get x alone here, you can see that all we have to do is multiply both sides by 12.9. So I'm going to multiply this side by 12.9 and cancel, and then I have to multiply this side by 12.9. So on my calculator, I'm going to do the sine of 63 times, oops, forgot a parenthesis. Guys, oh my gosh, times 12.9. Okay, so we're rounding to the nearest hundredth, that's 11.49. So we get x equals 11.49. And that's our QR. Okay, we have to find the length of FD. We should be saying of. Okay, so FD is our hypotenuse. We can call that whatever, and we can call it Z if we want. So compared to the 39, the 20 is the adjacent. Did I forget units on these? Oh, good grief. Let's go back and look. I'm sorry. I did. Okay, the first one is in feet, so I should have said feet. Okay, and then the next one is in centimeters. So Mrs. W should have said centimeters. Sorry. I'll do better. Okay, so with respect to our 39-degree angle, this 20 meters is our adjacent side, and the Z is the hypotenuse. So the ratio that uses adjacent over hypotenuse is cosine. So we are going to use cosine. So the cosine of 39 degrees is the adjacent over the hypotenuse, which is the 20 over our z. Okay, our z is in the denominator. That's a little bit unfortunate, but it's easy to fix. All we have to do is cross multiply. So we can do cosine of 39 times z, cosine of 39 degrees times our z equals 20 times 1, which is 20. And then to undo multiplying by 39 degrees, all we have to do is divide by cosine of 39 degrees on both sides. Because the cosine of 39 degrees is just a number. You can put it in your calculator, and your calculator will give you an estimate for what it is. So these cancel, and I get z equals, and I can just, on my calculator, do 20 over cosine of 39. 20 divided by cosine of 39, 25.74. 25.74. I'm going to remember my units. These are meters. Oh, and that was FD. FD. Okay, sorry, I was just seeing how many more there were to do because I don't want to make this video last forever. Okay, we have to find the length of DF. That is our hypotenuse. Okay, and our 17, if I look at this 51-degree angle, the 17 meters is the opposite side. So if I'm using opposite and hypotenuse, I'm going to have to use sine. Use sine. So the sine of 51 degrees equals the opposite, which is the 17, over the hypotenuse. Let's call this, you want to call it x, doesn't matter, over x. Now, again, my variable is in my denominator. So in order to get that variable up to the top, I can cross multiply. Okay, that gives me sine of 51 degrees times x equals 1 times 17 is 17. And then to get x by itself, I can divide both sides by sine of 51 degrees. Okay, those cancel, and I can put in for my x on my calculator 17 divided by sine of 51. Okay, just to remind you, make sure that when you're doing these, you've gone to mode and you're not on radians, you're on degrees. Okay, radians are it's like inches compared to centimeters. It's a different way to measure angles. So if you're not in degrees, you're going to be way off. So make sure you're in degrees. Quit out of there. I already forgot what I'm doing. 17 divided by sine of 51. Okay, 17 divided by sine of 51. And rounding to the nearest hundredth, that gives me 21.87. So x equals 21.87. These are meters. And x was my hypotenuse FD. All right, that's a lot so far. We're going to skip to the back. And do this word problem. Okay. I'm not even going to say that word. This building in, oh, what? Okay, it's a railway. It's not a building. This railway is the world's steepest cog railway. Its steepest section makes an angle of about 25.6 degrees with the horizontal and rises about 0.9 kilometers. So here's the horizontal. Okay, it says that at its steepest point, this railway makes an angle of about 25.6 degrees. 25.6 degrees from the horizontal. It says that it rises about 0.9 kilometers. That's telling us the height for that section. 0.9 K. To the nearest hundredth of a kilometer, how long is this section of the railway track? Okay, so this in blue, light blue up here, is the railway track, and that's the hypotenuse. So this is what we'll call this L. This is our hypotenuse. L for length. How about that? Okay, so with respect to this angle, my 25.6 degree angle, the 0.9 kilometers is the opposite. And we already said that the length of the track is the hypotenuse. So if I'm using opposite and hypotenuse, I have to use sine. Okay, so the sine of 25.6 degrees is my opposite, which is 0.9, over my hypotenuse, which is my length of my track. And to get my length of my track in the numerator and not in the denominator, I can cross multiply. There's a 1 under here. Okay, so that would be L times the sine of 25.6 degrees equals 0.9. So you can see that to get L alone, the length alone, I just have to divide both sides by the sine of 25.6. Which is just a number, it's a ratio. Okay, so L equals 0.9 divided by 25.6. Did I get that right? My short-term memory is garbage, guys. I'm sorry. Yeah. Okay. Yes. So that is, what did they say? To the nearest hundredth of a kilometer. Okay, nearest hundredth. So that is 0.04 because the 5 makes it closer to 0.04 than to 0.03. So 0.04. 0.04 kilometers. That doesn't look right. Did I accidentally get in the wrong mode? Oh, I'm in degrees. All right, let me see if I can figure out why that doesn't look right. Okay, I'm going to tell on myself and tell you what I did wrong because I definitely messed up. So the reason that I knew this was wrong is because my hypotenuse should always be my longest side. And you see that 0.04 is not bigger than 0.9. Okay, so I knew that I messed up. It is not this. So when I went back and look at my calculator, you can see that I didn't divide by the sine of 25.6. I just divided by 25.6, like a Nimrod. Okay, so that's what I did. So what I should have done is do 0.9 divided by sine of 25.6, and it should give me 2.08, which makes a whole lot more sense. So my length is actually, what was it? 2.08. 2.08 kilometers, which is longer than 0.9 kilometers and is a good length for my hypotenuse. All right, sorry that I'm a goober, but hopefully it keeps you from making that mistake.